So, hello and welcome to my next tutorial, which deals with the supply chain model. We had already a model where we generated a little supply chain, and now this model is extended to multi-item. So that means the customer is now able to order different types of items. In total, we have 3 players in the supply chain. We have 4 retailers, 1 wholesaler, and 1 producer. Those 3 players are within the region of Upper Austria and Lower Austria. The model has been generated with Anylogic Professional, and a standalone model has been generated. So you do not need the Anylogic software to run this model. You just need to install Java, and then you can use the applet generated by the professional version. Mainly the file consists of 2 input files. So one file, the input simulations Kosten parameter, refers to the cost parameters which you can adjust. And the other file is the Optimierungsparameter file optimizing parameters. So all the possible optimizing parameters, mainly the Kanban parameters, are in this file, and you can change them regarding which experiment you have launched. So that means the Anylogic file is reading those 2 files and generates the model based on that input. After the simulation or the experiment has been finished, all the results are stored in the result file, which is called FB Ergebnisse. There you find all the results, including the optimizing parameters, so that you can afterwards do a proper statistical analysis. The model also comes with 3 types of experiments. So you find experiments for Mac and Windows. Basically, you find parameters combination, a parameter variation experiment, and the classical simulation experiment where only one seed with the chosen parameters are executed. So in the following slide, I'm trying to explain the input files a little bit more closer. So we can see here the input files for the simulation run itself, for the simulation experiments. You can see here all possible Kanban parameters within that model. We see here the number of Kanbans for the retailer. We can see here the size of Kanban for the retailer, both for product 1. Then we have the number of Kanbans and the size of Kanbans for the retailer for product 2, for product 3. That means all retailers, we have 4 retailers, behave in the same way. Then we have the 3 products at the wholesaler. So we have the number of Kanbans for the wholesaler at product 1, the size of Kanbans for the wholesaler, and we have that for product 2 and product 3. And finally, we have also for the producer the number of Kanbans for product 1 and the size of Kanban for the producer product 1. And then you see also the product 2 and product 3. Here you can just enter the value. So in that case, for instance, we have 10 number of Kanbans for the retailer chosen for product 1, and the size of the Kanbans is 100. So please do not change those check values. This is just necessary when you made some mistakes in entering those values. And once you have configured it, then you could immediately start the experiment simulation, either on your Mac or on your Windows machine. The next one is the parameter variation. You see here the same Kanban parameters. You can select, similar to Anylogic, to the experiment parameter variation, if the parameter is fixed or you change it to a range. Then if there is a range, then you can define the minimum value, which is 10. The maximum value is 12. And I have defined for this example a step size of 1. That means we have defined 3 iterations, namely 10, 11, and 12. And we conduct here replications, which are 3 replications per iteration. So the total simulation runs conducted by these parameter variations are 3 times for the iterations multiplied by 3 times for the amount of replications. You can change that amount to an arbitrary number, so you can change it to 10 or 100, but please keep in mind the simulation time is now, compared to the other models I have selected or introduced so far, much longer. And finally, this is a new experiment. This is a combination of the standalone simulation run, but you have the advantage to define replications here, and you can enter unique parameter values for your Kanban parameters, and all those 3 settings are tested then immediately when you start this experiment. So the advantage of that is that you have the possibility to run replications, and you can predefine the set of parameters. So, and now let me switch to the model itself. When you unzip the model, then you have those beautiful files in your folder. You can also see the Anylogic model itself. You can open it with the PLE version to observe how the model has been implemented, how the additional products have been implemented in the retailers especially. And therefore you can see the standard files coming with the Anylogic model. But you're not able to complete the simulation run in the Anylogic model itself because it exceeds the 50,000 generated items. That is the reason why we have, or why I have provided the model generated by the professional version. And here you can see the 3 experiments for the Windows machines, the parameter combinations, the parameter variation, and the simulation experiment. And those are the 3 files when you use a Mac machine. Again, the parameter combination, the parameter variation, and the simulation experiment. Here you can see the 2 input files for the optimizing parameters and the cost parameters. And here in the beginning, you see the Excel file for the results. Within the model, you can decide if you would like to export the files in an CSV file or an Excel file. So that's the reason why those 2 files are there. And this is then the final outcome after you have used the professional version to generate the model in the standalone version. This is then the jar file, which is basically the model. But within that model, you're not able to do any changes. So for the purpose, we're using it to train experiments with Anylogic. So here here you are able to see the model itself. Unfortunately, most of the names is a mixture between German and English. I was not able, since I do not have so far here in Groningen the professional version, to adjust the naming to English only. But nevertheless, we can run the model. Then the Java applet is generated. And we see how the model looks like. Here you can define the output if you prefer Excel or the CSV file. You can see the name of the file where the cost parameters are selected. The same goes for the optimizing parameters. And in the end, you see the result files, both for the CSV files and the Excel files. And then we are ready to run it. Then it's starting up. I make a pause. So we can see here now the beautiful landscape of Austria. So that one, the orange one, is Upper Austria, and our producer is located in Lower Austria. We can see the locations of our 4 retailers, which are located in Steyr, in Wels, in Linz, and in Hagenberg. And finally, we have a wholesaler as well located close to Gmunden. And we have not changed the relationship between the producer and the wholesaler. This is still a one-to-one relationship. And we also have not changed the relationship between the wholesaler and the 4 retailers. So there we have a 1-to-4 relationship. But what has been changed within the model is that a customer is now able to order 3 different types of items. The same, so we also have not changed that the producer owns the trucks which are serving between the producer and the wholesaler. The wholesaler also owns trucks, and those trucks are responsible for the transport between the wholesaler and the 4 retailers. You can have here by those buttons a closer look to the retailer, to the wholesaler, and the producer. So if you go to the wholesaler, we can see already the extension happening for the multi-product situation. So in the former model, we just had one Kanban which was responsible for our products. Now we have duplicated it to 3 Kanban circuits, and each Kanban circuit is responsible for 1 product type. So product 1, product 2, and product 3. And when we have to refill the inventory of the wholesaler, of the retailers, then it is sent to the wholesaler. So you can also observe what's happening here. If you go to the wholesaler, you can see the same procedure that we have duplicated it for all the 3 products. And then the procedure, as we had it before in the other model, takes place. When items are available, then the transport is executed and the items are sent back to the retailer. If the items are not available or the Kanban is empty, then we have to reproduce those empty Kanbans, and then we send the agent back to the producer. So then we can go to the main, and we can also see the producer. So you can also see that we have in the producer 3 different shapes available. So here, of course, you could do some changes, but you should finally use then the applet, and we are doing that now. So I want to show you now the 2 input files. So I have opened the cost parameters. Here you can see all the available costs. So the intervals, how an order arrives, the processing times at the producer, the setup times for both 2 machines, station 1, station 2, the number of trucks, the speed, the volume of the truckload, 500 pieces, warm-up phase, runtime, and the 2 loading times for the minimum and the maximum at the producer. And we can see here then the real cost factors. Please check if these cost factors correspond with the outline given. You see the holding costs, you see the order costs, and finally the tardiness costs. So the EH is the retailer, the GH is the wholesaler, and the PR is the producer. And please double check that with the outline. Then we can go to the file for the parameters. We can see here on the bottom 3 sheets. The first one is the simulation experiment, followed by the parameter variation and the parameter combinations. Whenever you are done with the specification, which run you are interested, then you can immediately start the model. And now we take the standard configuration. So for the simulation experiment, for the parameter variation, so as we have discussed, we have 3 iterations multiplied by 3 replications. And for the combination, parameter combination, we have 3 iterations defined and just an amount of 2 replications. So I advise to close all the files before you start simulating. And then we take the first experiment, which is the simulation experiment. You can see the batch file is starting the jar file, and here comes the model. So we are not anymore using Anylogic, we are just using the standalone version. We see a similar Java applet, we can run it, and then you have the same functionality for observing, but now you're not anymore able to change the blocks or the coding of your model. We can run it as fast as possible. You can see I'm using a fast machine, so we can wait for the simulation results. In your case, that might not be so fast, yeah. So that is also one of the reasons why you have to think before you start your optimizing problem, which cost block do you want to reduce, at which stage of the supply chain. Perhaps use some analytical methods we have covered in that course or in the previous course by a colleague of mine, and then enter your iterations in the Excel file. Then we stop it, we close it, and we can see that we have now results gained. It's 1149, so we can open that, and then we should see that we have an experiment stored here in this file. There are already 3 other experiments conducted, so we have added now 1 result here. We can see here the numbering. You can see the cost factors again you have specified in the Excel file. You can see here then the outcome, the result, the holding costs, especially then the order costs, and then the cardiness costs at the retailer. And then the final result of the overall costs is also stated in the end. And your target is to minimize the overall costs in the whole supply chain. We can now also have a look to the parameter variation. So I have to accept it, that it is safe. So now the Java applet is generating again. Java applet is here. We can see here in a beautiful way which parameters for the retailer, for the wholesaler, and for the producer are available. And based on the file of the input file, those parameters are changed or selected. I closed that file as well, and then we can start running. In total, we need 9 simulation runs. Yeah, so we can see that the first run is now on the way. We can see here how many iterations have been completed. We can see that we are working with the first iteration. In total, we have 3 iterations and 3 replications, and now it takes unfortunately a little bit of time. So now we can see that we have already completed 2 iterations, so the progress is going on. So we are almost done with the little experiments of the 9 simulation runs. So, and now we can see the experiment is done. So all 3 iterations are completed, everything is green. We can press on stop, we close that one. And the Excel file is also transferring the results, 1152. We start the Excel file. And now we can see that we have hopefully 9 simulation runs. The count is 9. So we have our 9 replications. You can see as well iteration 1, 2, and 3 with the corresponding replications. We have all the results transferred, and now you can analyze them, calculate confidence intervals, for instance, to see if some of those configurations outperform the others, and you can continue optimizing the problem itself. And finally, we can also try the parameter variation. It takes a long time to save now, for whatever reason. But what we are going to do is in the meanwhile to start the parameter combination to see that that is working as well. So the Java applet is coming. Excel is not closed. Yeah, now it's closed. So we are ready to go. We are running the parameter combination. So keep in mind, those are the 3 sets we have predefined, and we have installed 2 replications. So 3 sets, 3 iterations, and 2 replications for each. So ready to go. And we are on the way. So the run is also finished. Everything is green. We can stop it. We close it. Transfer of results also took already place. So we open Excel. So here we have the 9 runs for the parameter variation, and here we have the 6 runs for the parameter combination. So everything works, and my suggestion is that you work to get familiarized with the Anylogic model itself to see how the logic is implemented. When that is clear to you, then you use the simulation experiment and the parameter combination to get grip on the system itself. And when you know what and how to optimize is that you use the parameter variation to prove in the end also that your results are significant, and the minimized costs in the end have to be proven by 50 replications. And there it would be nice to show also how your other iterations perform. Good luck with it.